Let's continue with the formulation, the third and last video about uh, hydrates. We're going to finish with hydrates and these three groups will be this one, boron, which is the third, group 14 with carbon and silicon, 15 with nitrogen and phosphorus. And then when we talk about hydrates with oxygen, is 13, 14, 15, and 16 oxygen. Okay, good. As I said here, boron is a semi-metal. It's in yellow in this periodic table. Carbon is non-metal, okay, in green, and silicon is in yellow and is semi-metal. Nitrogen and phosphorus are non in green, non-metal, and oxygen, of course, group 16. When you mix it with hydrogen, you obtain water. Good. Group 13, boron, in this case has +3 oxidation number. We write it close to hydrogen. We say boron 3 hydrate. We use the prefix 3 to describe that there are 3 hydrogens. Okay, and we have in this case we don't have stock nomenclature, so we're going to call it borane. And all these finish with ane, methane, and silane. Okay, group 14, carbon, non-metal, oxidation number 4. We put it with the hydrogen. We shift the oxidation number of carbon. We put it close to hydrogen here in the right. And then we have carbon tetrahydrate, sorry. As I explained here, we use the prefix tetra to describe that there are 4 hydrogens, okay? Good. Silane, in this case, oxidation number 4 is also, as you can see here, semi-metal, okay, with boron, that makes borane. Okay, that's great. And we call it is exactly the same as carbon because both of them have the oxidation number 4. Silicon and tetrahydrate. Tetra here means that we have 4 hydrogen. Okay, and how we call it in the commercial name, we have silane, okay, that from silicon, and that's a commercial region. We next 3 elements to finish with these groups. Group 15, sorry, again nitrogen has 3 oxidation number. We write it close to the hydrogen. That makes nitrogen 3 hydrate. Okay, and how we call it? Ammonia. Phosphorus, the same. Okay, we're oxidation number 3, so we write 3 close to the hydrogen here. Okay, is the same as the previous example. Phosphorus 3 hydrate, very simple. Phosphorus 3 hydrate, nitrogen 3 hydrate. How we call it? Phosphane. Okay, phosphane. The other ones also have ane at the end of the word in a commercial name. Ane, like borane, methane, silane, and the next, ammonia is an exception. Ammonia is an exception, but we have phosphane. And again, in this case, we write it the other way around. We write it first hydrogen and then oxygen, what makes two hydrogens. We shift from the number of oxidation number of oxygen. Okay, we forget about the systematic nomenclature or name, systematic name. So we are going to have the commercial name, which is water. Non-metal hydrates. Okay, we're going to focus in the groups 16 and 17. And instead of having a systematic name or a commercial name in the previous two slides, we are going to have aqueous solution. Okay, well, and we call it this kind of aqueous solution are acids. Okay, group 16, oxidation number, and all of them -2 here, -2, -2. Okay, so all the way are the same. Hydrogen sulfide, hydrogen silane, hydrogen tellurate. Okay, so 2 hydrogens and 1 sulfur, hydrogen sulfide, 2 hydrogens and selenium, we have hydrogen selenide, 2 hydrogens and a tellur, we have telluride. Okay, telluride. Why we don't write dihydrogen? Because this is the only hydrate of sulfur that exists. Okay, hydrogen selenide, the same. Why is not dihydrogen selenide? Because it's the only hydrate of selenium. Okay, and H2Te, 2 hydrogens and 1 tellurium. Why we don't have dihydrogen telluride? Because again, is the only hydrate of tellurium. And what happens when we put it with water? That this component is called hydrosulfuric acid or ácido hidrosulfúrico. Again, with hydrogen selenide, hydroselenic acid, in the tellurium or a hydrogen telluride with water, it has this name, hydrotelluric acid. Again, hydrosulfuric acid, hydroselenic acid, and hydrotelluric acid. Okay, hydrosulfuric, hydroselenic, hydrotelluric. Okay, sulfuric, selenic, and telluric. Okay, IC. Okay, good. Group 17. Okay, with the halogenous elements. Good. All of them has -1 as an oxidation number. Oxidation number -1. Okay, we write again hydrogen and then the element, hydrogen, the element. And because both of them have 1 as an oxidation number, we don't write it. Okay, so hydrogen fluoride, hydrogen chloride, hydrogen bromide, hydrogen iodine. Okay, this is kind of an exception. Okay, Good. Why not mana? Not needed. Again, all of them are only made up of one atom of each, one hydrogen, one fluorine, and so on and so forth. When we mix it with water, hydrosulfuric acid, hydrofluoric acid, hydrochloric acid, hydrobromic acid, hydroiodic acid, okay? Hydrofluoric, hydrochloric, hydrobromic, hydroiodic, okay? Acids, all of them.